Hey everybody, in this video we are starting off section 2 of the unit on exponential and logarithmic functions, and section 2 is an introduction to logarithmic functions. So what the heck is a logarithmic function? Why does it exist? What is going on? I'm going to show you a bit of an introduction, and I'm going to do that by talking about inverses just for a little bit. So inverse. If I had a function, for example, y equals 2x minus 3. That is a linear equation. It has a y-intercept of -3 and a slope of 2. And as a graph, if I needed to graph that, it's going to look something like that, give or take. Not my best. Right? So there, it's got a slope of 2, up 2 over 1, yada yada. There it is. Now, does this pass the vertical line test? Yes, it does. Does it pass the horizontal line test? Yes, it does. What does that tell me? That tells me that this happens to be an example of a function that is what we call one-to-one. That means that not only is this one a function, but so is its inverse. Its inverse will also be a function, and we're going to focus on those at the moment. Now, how do you algebraically find an inverse? Algebraically, we find an inverse. We start off by switching in the equation, quite literally, the x and the y in the equation, which in turn switches your domains and ranges, and then we solve for y. So if I were finding the inverse, I'm going to start off with x equals 2y minus 3. Then I'm going to solve for y. I add 3 to both sides. X plus 3 is 2y. And then I either divide by 2 or multiply both sides by 1/2. And I'm going to be careful how I choose to write this. So I'm going to call this y equals, I'm writing my y on the left, and I'm going to put a 1/2 out front of the quantity x plus 3. Now, if I were to graph this one using transformations like we did in an earlier unit, that would be moving to the left 3 units. So instead of going down 3, I go left 3. And then instead of having a slope up 2 over 1, up 2 over 1, this has a slope of 1/2. So up 1 over 2, up 1 over 2. And this graph will look something like that right there. And they happen to intersect and be symmetric over that purple line. And that purple line right over there is the equation y equals x. That is what we call the identity function, and that's what it is. Now, composition. So a composition you may have seen written out as something like the f of f inverse of x, f of g of x, whatever way you want to call it. I'm not going to do it both ways. I'm going to do f of f inverse for this particular example. So if I call the original f, and if I call this guy over here f inverse, and I compose them together, well, what happens? Well, let's talk about the word inverse. What does the word inverse mean? The inverse operation is an operation that will undo another operation. So addition is to subtraction, multiplying is to dividing, square to square root, right? But an inverse equation or an inverse function is going to be a collection of operations that basically undoes all of the other operations. So what will that look like if we compose them, put one within the other? 2, let's even actually keep the colors the same. So 2x, so this is x normally, minus 3. Now in place of where x was, I'm going to fill in my inverse function. So 1/2 quantity x plus 3. Now what happens when I clean this up? When I clean this up, the first thing that will happen is the 2 and the 1/2 are going to reduce down to a 1. Then my parentheses are sort of obsolete at this point. I absolutely don't need them. And then plus 3 and minus 3 are gone. And I'm left with x. All right, interesting. What else is there? How about the example? Let's just do one more. Y equals, say, the cubed root of x minus 4. So x minus 4 is all under my cube root. And then plus 5, right? Now, is this guy 1-to-1? Well, what does this graph look like? It's going to be right 4 and up 5. So I'm going to move my parent function right 4, up 5. So somewhere over here. Now, a cube root, what does that look like? It looks something like that. And then it turns this way. So, just a sketch. It looks something like that, right? Now, is this guy going to pass the vertical line test? Yes, definitely a function. Does it pass the horizontal line test? Also yes. So again, that tells me that this is, like the last example, 1, 2, 1. 1x for every y. That there's no funny business. No one's cheating on anybody else, right? So that means the inverse will also be a function. So let's go ahead and find that inverse. Start off by switching x and y. So I end up with x equals the cubed root of y minus 4 plus 5. I'm going to subtract the 5 over, x minus 5 equals, and while I'm at it, after I brought that over, let's cube both sides. So I'm going to get x minus 5 quantity to the third equals y minus 4, and the last step is to add the 4, and I'm going to write the y on the left. So x minus 5 cubed, and then it's plus 4. So there I go. There's my inverse. Now what does that graph look like? Well, it's a cubic parent function, so that one has that shape over there. I'm going to go to the right 5 and up 4, so I'm going to be about there. And it's positive, and it's going to have a shape sort of like that right over there. And again, it's symmetric over that identity function, y equals x. So let's see what happens if I compose those together. This time, let's do f inverse of f of x, right? So what is going to happen? So my red one will be my outer function. So I'm going to have parentheses, leave some room for x, minus 5 to the third plus 4. And then I'm going to fill in the cube root of x minus 4 plus 5. And the plus 5 is not under the cube root. And now what happens? Well, the plus 5 and the minus 5 are gone. The cube and the cube root are gone, inverse operations. And now that minus 4 and plus 4 also gone, and I'm again left with x, right? Once again, I'm left with just x. So what happens is, if you have an inverse function, if we compose them together, no matter how simple or complicated they are, how many layers there are to them, we will basically be left with just the input of that. So in this case, x or whatever. So let's come up with what a logarithm is. So I'm going to do the most very basic exponential. Y equals, now in the earlier videos, I use capital B for my base all the time because lowercase b is usually my horizontal stretch or compression. But in order to be consistent with most other math textbooks out there, I will use lowercase b in this instance. So y equals b to the x power. This is the most basic exponential function, right? Maybe the base is 2, maybe it's 1/2. We don't really know. If it's 2, right, that would be a 1, then that would be over 1 up 2, over 2 up 4, and so on. So the graph will look something like this over there. It doesn't really matter whether it's a base of 2, a 3, a 4, a 1/2, whatever. The same argument will be true. So there we go. That is my exponential. And that's what we introduced in section 1. Now, is this going to pass the vertical line test? Yes. No matter how steep it gets, it does pass vertical line test. How about horizontal line test? Yes. And again, no matter how flat it gets, as it approaches 0 to the left, it's still going to pass the horizontal line test. So what does that tell me? This is indeed 1-to-1. This is a 1-to-1 function. Now, that means it's a function, and its inverse will also be a function. So how do I algebraically find an inverse? Well, we said first thing you do is you switch x and y. So I'm going to start x equals b to the y. Now, how do you solve for y? I'll wait. Before log, to solve for y was really only something we could do maybe in our heads if we were lucky. For instance, if I said to you, and by solve for, I mean to get the answer over here, right? Like solve and figure out what that equals, or, no, I'm sorry. Don't listen to me. That's not what I meant to say. To solve would mean to solve for that right there, what y equals, right? Your output. So if I had something like 2 to what power is equal to 8? Well, I could solve that in my head. It's 3. But what about 2 to what power is 81? I don't know exactly. I know it's bigger than 6. 2 to the 6 is 64. I know it's less than 7. 2 to the 7 is 128. But what 2 to what's 81? I mean, I could do a little intermediate value theorem, meaning like I kind of keep picking until I narrow it down to exactly what the value is. Well, as best I can, at least. I guess I could try that. But log allows us to figure this out. It's all programmed for us in the calculator. It's probably using some linear approximation from calculus and programmed into the calculator. So what did mathematicians decide they wanted to do to solve for y? So they had to invent an operation. Just like for adding, we invented subtracting, right? Multiplying, we invented to unmultiply or to divide, and so on. So how do I undo this exponential with the base situation? So they're like, oh, we got you. We're going to do the following. So what we end up doing is, let's pick a different color. Okay. They're like, all right, so what we're going to do is we're going to take this thing called a logarithm, and the base will match the base of the exponential. And we'll take the log of the left side, and we're going to take the log of the right side, log base b of each side. And what are we taking log of? Well, here x, and on this side, b to the y. And by definition, by design, the log is going to undo the exponential. So log base b and b as a base are gone in this situation. And the only thing that's going to be remaining on the right hand side is a regular size, no longer teeny tiny, y. So x equals b to the y, also known as b to the y equals x. Make sure that you know that that's an exponent, y. I feel like that y is a little bit large and in charge for my liking. B to the y equals x. All right, I just reversed it. That is what we call exponential form of the inverse of exponential, which is a logarithm. And then the form with log in it over here is going to be a logarithmic form. So let's continue. Here is that final definition. Location of base and exponent in exponential and logarithmic forms. So you're going to want to write this down. You could color code and organize it that way. And what is it going to look like? Let's see. So the base, right? The base is in the basement of the log. It's down low on the bottom. And the base is the thing being raised to the power in an exponential form. So there's your base. Then the exponent, let's say, right? Where did that go? So the exponent was y over here, right? And that's over here on this form. And then the last thing that is remaining, right, is the x over here. So just know where everything goes, right? And know the name of everything. So again, we have logarithmic form of our exponential. And then we also have exponential form. And these are one in the same. Okay, so we have to be very comfortable going back and forth. And if you're ever unsure, I've always just been really of the type to memorize a solid example as my go-to, so I know how to rearrange it. And what is my go-to example? My go-to example is log base 2 of 8. Now, how do I read this? This says to you, 2 to what power equals 8. That is how we can read it. 2 raised to what power equals 8. So we're solving for the exponent. And what is the answer to that question? The answer to that question, is 3, right? So you could look at it with the 3 on this side, right? Or we could look at it as log base 2 of 8 equals 3 with the 3 on this side. Doesn't really matter. It's also important to note that the 3, the equal sign, the word log, and the 8 are all of the same size. They're like your regular text font size. The exponents in the exponential form are superscripts, so they're up higher, right? And the log base 2, the way I read that off, that 2, that little 2 down there is a subscript. So it's a little blending together. So I'm just going to color coordinate so we can separate them in case you're looking at my mess over here and like, wait, where's that 2? Is that 3 squared? No. So there's one way to write it, right? And then the other way to write it was, do I have a color? I haven't used that. Not really. How's red? Is that too dark? This is just with it on the other side. You get what I'm saying? Right? Maybe that's a little squashed. I'll do us a favor. So that was just the one order, and then get that out of the way. The other way is just log subscript of 2. 8 is up here. Sorry, my 8s are always so, I don't know why I write like that. Equals 3. So the 3 could go on the left or on the right. It does not matter. And again, the way we read it, don't say log 2. It's log base 2. Okay? Just to be a little nitpicky. So if you kind of know the structure this way, and you know that it means 2 to what power equals 8, then you know it's saying 2 to the 3 equals 8. Like, these are both equivalent statements, right? Equivalent. I don't like that the word equivalent's cut off. These are both equivalent statements, okay? So whatever you need to do to remember that they are the same statement, you do that. And this way you have a go-to example to rely on every single time. So equal statements. Talking about that, and even this over here. Right? So those are all equal, and that's essentially what log is. That's my major introduction. So can I do some examples? I guess I can. But I'm going to do it in the next video because I feel like this one is so long already. But I just feel like it's important for people to understand. So maybe you watched it in double speed. You got a little bit under 9 minutes over there, about 8.5. Apologies that I went on. But I just feel like not everyone does a really great job explaining this to students. And then, you know, it's not always your fault that you don't understand. Your teachers do a crap job and they just sort of give you a little bit of nothing to work with. And you're trying to memorize, but you have no level of understanding. And it makes it difficult. All right, so that's the end of that. I hope that this explanation allows you to understand what log is. It's just like sine inverse is the inverse of sine, etc. So if you love it, thumbs up. If you don't love it, if you hate it and hate everything, go ahead, thumbs down. Questions, comments, concern, requests, and feedback in the comment section. Check the video that's popping up on the thumbnail now. Check the playlist, check the description box for more. And I will be doing a bunch of examples right after this upload. So bye for now. Adios.